Okay. Good morning, everybody. Thank you for joining us on this finally sunny Thursday for this water issues seminar. We have Brian Rivers with us again to talk about his experience with Engineers Without Borders. Brian is a compliance engineer in the Community Public Water Supply Unit over at MDH, and he's been working on implementing the PFAS MCLs, the National Primary Drinking Water Regulation. So he coordinates contract work associated with monitoring requirements, compliance with the MCLs, and has been helping with the dashboard of data from water testing, which you and Bill presented on not too long ago here. Prior to joining MDH, Brian earned a bachelor's in civil engineering from UW-Platteville and has a master's in environmental engineering from Michigan Tech and served as the water, sanitation, and hygiene volunteer with the Peace Corps in Peru. So, Brian, thank you for joining us today. I'm glad that your computer is not trying to push any operating system updates this morning, and kick it over to you.
Yeah, well, thank you, Fox, and thank you everyone for letting me reschedule this presentation. Unfortunately, the last month when we tried to do it, I prolonged the Windows 11 update one day too long. So I turned on my computer and it was like, nope, you are not doing anything for 2 hours. So thank you for letting me redo this. So without further ado, and thank you for the introduction. So again, I'm Brian Rivers. Like Fox said, I work at MDH, work a lot with PFAS. But before I was at MDH, I did a lot of work in kind of the global wash sector, both through Engineers Without Borders, which we're going to talk about today, and the United States Peace Corps, which I'll touch on briefly. But they have miraculously kind of overlapped in the country of Peru. Both, so that's where I did my service, and then just so happens that the Minnesota chapter, Minnesota professional chapter of Engineers Without Borders, also happens to work in Peru. So really serendipitous, and just kind of been such a cool way to kind of extend my skill set that I've developed over those 2 years and now can keep applying it. So, and today we'll talk about what that Minnesota, there's a couple of different Engineers Without Borders chapters in Minnesota. There's the professional chapter, which I work in, and then there's also the U of M student chapter. So we all cover different projects in parts of the world. But if you hear about Engineers Without Borders, there are many different actual disparate chapters, not only in the state of Minnesota, but across the nation as well. So without further ado, let's talk about this particular trip that I went on almost exactly a year ago. We got back, and it was the third implementation trip for this community known as Chuchurras. And that is a community deep in, I shouldn't say so far deep, but it's in the kind of jungle region or Amazon region of Peru. It feels like you're very far because it takes a long time to get to, but really you're actually not too far. And I'll show this on the map at some point. From the Andes, just kind of coming off, they call it the eyebrow of the jungle. So you're not quite into the jungle, but you're not quite out of the Andes. So you're kind of just in this very nice temperate region of Peru. So yeah, the image that you're all seeing right now is kind of towards the end of our trip, where we posed with the community. They had this kind of nice celebration, just kind of marking the end of this phase. So that was really just a really cool day and really special to get together with them. So I think that's how I navigate through here. Just click on each one of the slides. Oh, I can just navigate forward. There we go. So again, my name is Brian Rivers. I work in the United States Peace Corps. I'm from 2018, right up until the pandemic. So that was kind of, I actually got my full service in, unlike many of my peers who had to be evacuated like midway through their service, or just when it was starting. So luckily I got a pretty broad experience. And so I lived with the host family. So here's Lily and Eugenia when I got there. And then when I was shipped out to site, so I lived with Lily and Eugenia in Lima for 3 months, just kind of learning the language, learning about Peruvian culture, trying to best understand how we can take our skill set from the United States and apply that in country. And then this is Steve on the left here, and then Jose in the middle. And then that's, of course, me. And we're in Steven's site of Recuecito at about 10,000 feet. And so we were just kind of going around, like MDH has something known as district engineers, where they kind of go out and do some of these sanitary surveys, and they help train operators and work with them one-on-one. And that's really analogous to what we were doing in Peru at that time, as we would work with Jose, who's our local counterpart. He's kind of the person who's in charge, kind of the engineer in charge of the systems, and then we would travel with them to do some of these trainings and capacity building exercises, help systems inspect their system and apply for grants through the Peruvian government. I went forward here, there we go. Can you see that third slide where it says water, sanitation, hygiene?
Yes.
Perfect. Awesome. So yeah, here's some more just kind of images of what we were doing in Peace Corps. So we worked in the water, sanitation, and hygiene program. And so primarily we are like a drinking water focused program. But that's not to say that there aren't wastewater projects that occur. And then the hygiene component kind of relates to some more of like public health, more like one-on-one working with community organizations in local public health organizations, such as the health posts and the health, like tiny little clinics that they have in the district capitals, and going out and working with people on things like best ways to store water at the home or treat water as it gets to you, and or working with schools and trying to get kids to understand the importance of washing their hands before eating and things like that. Like really just a real comprehensive view of water and our relationship to it. And of course, not just doing that work ourselves, but trying to train local partners to do that for when we leave, because that's kind of the goal of Peace Corps, is to it's that adage of not just giving a person a fish, but teaching them how to do that. And obviously, there's only so much, like I probably did way more learning than I did ever teaching. Like when you get there, you kind of realize, oh yeah, people have known these lessons for a long time, but just there's such a gap in resources that sometimes those practices fall through. So that's kind of the bridge that we can kind of help provide. So in the pictures here, you're seeing some of our operator trainings on the right here, where we would work. So actually in the middle picture, the Peruvian government would come in and they would install some of this pretty nice infrastructure for these gravity-fed water distribution systems. But then they would install it and then basically hand the keys off to some of the local contacts and then leave. And they'd be like, hey, good luck. Like, you know how to work this, right? And they'd be like, sure. And then, may or may not be used properly, or, may just sit neglected for a couple of months. And so that's where, again, is a real big opportunity for us to kind of to fill in those gaps and say, okay, you may have this infrastructure now. Let's try to use it properly. Let's try to learn how to orient, or calibrate it to your specific needs in your community. So you can see Steve in the middle there, kind of popping his head out of the reservoir cover, and we were doing a limpieza, which is Spanish for a cleaning and disinfection of the reservoir. So we would kind of go in there, and Jose the municipality would provide some proper PPE, such as gloves and brushes and masks. And then we would go in there and learn how to kind of scrub it down, disinfect, fill it back up, disinfect it, and then purge it from the system. So, and then what you're seeing on the top there is actually their chlorine, their drip chlorination system that they would use to purify this kind of spring-fed mountain water. Excuse me. So And then once we had that chlorine in the distribution system, then we would go out and teach people how to measure that residual. And so that's what you're seeing Stephen hold here. We would use like DPD tablets and just measure with a colorimeter scale. It's kind of like a really kind of basic form of like what Hawk has in those like really fancy devices to read residual chlorine. So we were doing that with just DPD tablets and sunshine in Peru. So but which works fine as long as you know some of the characteristics of that water. So we'll keep going here. And so once once we were all evacuated, it was kind of like, oh, well, that was a sudden and unpredictable exit from service. But I kind of still had that like fire lit within me to try to like figure out and work with some of these water systems. And so I alluded to earlier that a lot of these are gravity-fed water distribution systems, which basically mean that like instead of having a lot of pumps or mechanical parts or any electricity, these systems work purely on gravity energy flowing from. So essentially, you would find a spring, or these communities would find a spring up on the mountain, and then channel that water, protect it, and then flow it downhill to a reservoir, right? And so that's kind of what I tried to and then from the reservoir, it would get into the distribution system, and then you could build out pipes to people's homes or communal taps and things like that. And so when I was at Michigan Tech, once the pandemic started, I enrolled at Michigan Tech, and my advisor and I kind of devised a small-scale version of one of these water distribution systems, which are known as intermittent water distribution system or intermittent water systems, as opposed to continuous service water systems, which like what we had in the States. So when we go to the tap, you can pretty much rely on the fact that you'll have water 24/7, right? Like, and then we work on the quality from there. But when you're working on a gravity-fed distribution system that's funneling water from a spring-fed source for a portion of the that may or may not be enough for your entire community, you might not have water continuously throughout the day. So for example, in the community that I worked in, I'll just go back a slide. So we would fill up one of these reservoirs overnight, and then in the morning, the operator would go up to the reservoir, open the release valve, and then send water into the distribution system. And so from 9 a.m. to 12 a.m., we would have great water pressure, and everyone would have abundant. You could cook, you could clean, you could do all of your issues. But when you have like an intermittent water system, that means that by 12 p.m. that pressure in that from the tank was really low, and that tank had pretty much been exhausted. And so when you're living in a developing community, there aren't nice things like water meters or automatic shutoff valves and things like that when you have too much flow from the system. So that means if someone leaves their tap open, likely water is just going to leave out of that, right? And so when you have water isn't secured all day and you don't know when it's going to be there, you're kind of more enticed to just leave that water open or leave that tap open from when it does come, right? So that's kind of some of these like ways in which intermittent water systems work. And a really long-winded way of saying that we basically tried to replicate exactly what's happening in these distribution systems at Michigan Tech. And so that was kind of some cool research I was able to do because as it happens, there's very little research on how these types of water systems work, even though that is how 70 to 80% of the world gets its water is through water distribution systems like this, which sometimes flow full, sometimes are completely empty, and so that has implications for some of the pressure and flow regimes that occur throughout the pipe systems like this. So thank you for listening to my TED Talk on intermittent water systems, and we'll get to what we actually did in Peru through Engineers Without Borders. So kind of a quick background on Engineers Without Borders. It's a kind of a nonprofit international organization founded in 2002 in Boulder, Colorado, out of the University of Colorado Boulder. And so it's not only international, we do have domestic programs as well as climate resiliency. But basically the overarching mission is to partner with communities and develop leaders to build a better world. And so I wonder if, oh yeah, okay, good. My animations are working here. So these are kind of the, our vision is to have a world where every leader is equipped to build and every community is built to thrive. So those are just kind of ambiguous ways of saying that we work with under-resourced communities, both home and internationally, to build, kind of sustainable infrastructure. And a lot of those partnerships are community-driven, right? So we're looking at, not only cultivating engineering skills and climate resiliency, but looking at to develop capacity within those communities to have leadership and to build, make connections throughout the community so that it's not so reliant on people coming from North America or so on and so forth to help them do that work, right? We want to work ourselves out of the job. So again, some of the programs that we have are international community program, and that's when you think about Engineers Without Borders, that's dominantly what we do. However, we're trying to expand what we do and take those lessons and benefit people in our own backyard. So, for example, University of Minnesota student chapter, they're actually working with a couple of drinking water systems in Western Minnesota that have like arsenic and radium issues. So that's been a really cool project that they've taken on. So, to really just trying to learn the work ourselves kind of out of that, almost colonialist type of mentality of like, oh, we need to go and help people elsewhere because we have so much stuff here. Whereas, we don't necessarily need to do that. There are people there who have, there are engineers in Peru, there are engineers across the world. So what can we do to better kind of allocate those resources? And if we want to do projects, let's do some that benefit right here in our backyard. So that's kind of some of that. We also have Climate Resilience Initiative. I'm not nearly as familiar with this one. I haven't met any programs that do this, but it's pretty cool. And obviously it looks like they're kind of installing solar panels and more kind of green infrastructure. So I wish I could tell you more about that, but unfortunately I've just never worked on a project with that. So, so again, kind of the idea is to leverage, engineering experience that we have in the professional communities here and develop multi-year partnerships throughout the places that we work. So it's never just developing one project and then taking a picture and leaving. It's again, a multi-year project where we do assessments. Maybe we'll work on one project that's kind of on the basic building blocks, and then we expand it out from there. Ideally, we're not just working with the community, but someone else within that community, another like a non-governmental organization, another nonprofit that can assist that community not only when we're there, but when we leave. Excuse me. And so our project, in our particular project, we have an NGO that works in a kind of the district capital, but they're able to go out into these communities and really figure out what resources they can give to these communities when we're gone. So if they have a question about maintenance or something breaks, they don't have to necessarily pick up the phone and call the people in North America. There's someone in their community that can help them troubleshoot and help them, even do some of the administrative stuff like saving for water, like saving for maintenance, saving for kind of a rainy day fund type of thing, and paying for upgrades to their infrastructure as they go. So we work mostly kind of from a sustainability lens, and as well as capacity building, doing things like knowledge transfer. So a lot of our projects so far has been focused on implementing the infrastructure, but once everything's kind of delivered and built and at a kind of that 90% or 95% phase, we'll start going to something called project monitoring and evaluation, as well as operation and maintenance trainings. So we essentially trying to establish a base. So we started before the project establishing a baseline of what they had, and then gauging kind of community interest and their particular opinions about this, trying to gauge their interest and their preferences about how this infrastructure is implemented throughout the entire process. And then we track that going into the future, just being able to say, okay, this is what we thought we wanted. This is what we've developed this project, and then this is how we're benefiting it or not benefiting it from it, going, 5-10 years into the future. And then we will also do operation maintenance training. So you'll see Ricardo here is in the middle. He's the leader of what's known as the HAS, or the Junta Administradores de Servicios de Saneamiento, which is Spanish for the local water community. And so he lives in the community. He's kind of our main operator. And so he's the one who knows the most about, how to, turn the pumps on, how to fix a lot of the tubes. But obviously he's one person. So our goal is to be, kind of take his knowledge base and help him train people within his community to replace him. And if he's gone or if he's sick or, so on and so forth, there's someone else who can step up and, perform some of these maintenance activities. So Minnesota Professional Chapter, obviously we're engineers without borders, but that is not totally limited to engineers. We also have architects, scientists, technicians. Even in our group, we didn't have exclusively volunteer engineers. We also had some technicians from SEH, people like CAD scientists. It would be really great to have like blue collar workers, I think, like actual water operators from Minnesota teach, water operators in Peru, some of those, do some of those best practices. But, so in that sense, the name is a little bit of a misnomer. But we've got to do a little better on our recruiting there. So, there we go. So we don't only work in Peru, but we also work in Guatemala, we work in Bolivia, and like I said earlier, we also have domestic projects here in Minnesota. So I've alluded to Peru, but let's talk about my favorite country outside the United States. So this is Peru. It's famous for being the seat of the Incan Empire. It's one of the most biodiverse countries throughout the world. I think I'm just shooting from the hip here, but I think once that I'd heard that there's like 120-ish like possible biomes that exist on planet Earth, and Peru has roughly like 85 of them. So it is an incredibly biodiverse country. It has some of the driest deserts in the world, some of the rainiest, contrasted with some of the rainiest and lush green jungles, which is like the start of the Amazon. And then you have these kind of the soaring Andes, of course, which is the second highest mountain range in the world. And so, if you've eaten a potato, if you've ever had beef jerky, if you've ever much of like our blueberry production, I found out, and banana production comes from Peru as well. So the food there is excellent. But yeah, it's a pretty excellent country. And so for those people who may or may not have visited or know where Peru is, so in orange, you have the United States of America here. And, in my mind, when I was, in grade school, I always thought that North and South America were directly below each other, but really South America is kind of offset, where their West Coast more or less aligns with our East Coast. So if you take a nice 7-hour trip from Miami all the way down to Lima, you'll be in Peru. And so in this picture, it doesn't look too like it kind of looks like a smaller country. But when I tell people about the size of Peru, I like to say that it's pretty much the West Coast states all smashed together. So for reference, there's Minnesota. And then if you were to take Washington, Oregon, California, and pretty much all, like most parts of Nevada, and then you probably some parts of Arizona and Idaho here, you would have roughly the size and shape of Peru. So by no means is it a small country. And yes, so where we work is kind of maybe north of Las Vegas, as I would put it, in the jungle region, just over the Andes. So being an incredibly diverse or culturally diverse, but also geographically diverse region of the world, getting resources to places can be pretty tough. And so water access, and these stats are as recent as 2016, so I apologize for giving you antiquated data, but this was the best way to kind of break it down as I could find it. But when I started my service, this was kind of a water access in Peru. So roughly 2/3 of houses had some form of water. That doesn't necessarily mean it was potable water, but they had some form of water access in their house. But a large chunk of the country does not have any form of water access. And that was very true in our community. And when we talk about sanitation, the access it's almost the opposite. 2/3 of people don't have sanitation access in their house. And so that's, quite a bit, a larger gap. And so we even knew that when we were working in Peace Corps, is that like, everyone wants to work on drinking water because that's kind of the snazziest, easiest, picture friendly, way to improve people's lives and deliver resources, right? But obviously that's not the whole picture, right? We want to think about the other half of wastewater, of water, is, I shouldn't say the other half, but another whole slice of that pie. And so I found out that many communities were much more hesitant to work with wastewater because, there's kind of that what do you call it, stigma around working with excreta and working with in channelizing waste and things like that. And unfortunately, that's that really lags behind in places throughout Peru, for all of the developmental reasons, but also cultural reasons and things like that. So that's kind of something that a really big opportunity to work on projects going forward here. And so even within this project, we're working on drinking water, but that community still doesn't have a form of wastewater system and collection and treatment and disposal. So that is definitely a huge opportunity that we have going forward to expand our impact in this community. And so when you're talking about not having, even when you have 2/3 of the country has water access, that still means a third don't, right? And so things like malnutrition, so waterborne diseases, when you're not having a centralized form of treatment or even a point of use treatment, things like Giardia, Cryptosporidium, all sorts of coliform bacteria can get into that water. It can make its way to infants and babies. And so when you have these waterborne diseases, you might not be able to absorb nutrients nearly as easily. So we're talking about, especially infants need iron and all sorts of other forms of nutrients to facilitate growth. And when you have diarrhea and you have all these symptoms caused by waterborne diseases, that causes those nutrients just to exit your body instead of being absorbed. And so anemia throughout all of Peru is a pretty persistent problem. So working on treating drinking water, getting safe sources of water is a huge priority, especially in rural regions. As you can see, pretty much half of the country is kind of in that dark red region, and or was at one point. And then everywhere else struggles with it as well. And that's just, again, speaks to so many different issues, but definitely to getting clean access to water in the home. So we were back in 2018, a local NGO reached out to us about this 500-person community named Chuchurras, which manually collects unclean water during the dry season from a local river. And so I think which best, just maybe I could, I'm gonna take a risk here and stop sharing. Actually, I wonder if I could, well, maybe we'll be able to see it in a different, maybe instead of going out of the sharing, I'll just show it within I had Google Earth open for you guys to look at. So maybe stop presenting and then I'll just share my screen. There we go. So this is Chuchurras, and we'll zoom way, 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 way out. The layers back on. There we go. So here we are in good old St. Paul. Take our flight down to Miami. Take our flight down to Lima. So here's Peru. So it's South America. They're on the west coast. And so we flew into Lima, and then driving all the way to Chuchurras would be extremely difficult because, there we go, maybe I like to put up the terrain. So there's our project community right here. There's Lima. And so we flew into Pucallpa, and we took a nice 7-hour drive through the jungle all the way into, so you can see the Andes Mountains here, and Chuchurras is just right as you're leaving, kind of in this nice little pocket nestled between a tiny little hill range and then the start of the Andes. And yeah, this is the community. So We'll go back to satellite view. So the community is really split into two different parts. It's 500 people throughout all of it. However, there's Santa Rosa on the southern bank, in San Francisco, which is up on the hill on the northern bank, and then there's the Chuchurras. Actually, I can't remember what the river. I call it the Chuchurras River, but I don't know if that's actually the name. But there's a river that flows through it, eventually becomes a tributary to the Amazon. But so when you're working in the tropics, they don't have quite the marked seasons that we do here. They don't have like an autumn, winter, spring, summer, right? It's usually the wet season and the dry season, right? And so during the wet season, there's abundant water, right? So the community had kind of an old, dilapidated drinking water collection system, but that only served the Santa Rosa side, which is on the southern bank. The San Francisco side, throughout the entire year, they had to drink from the river. And if you know anything about surface water, it's a very vulnerable content, it's a very vulnerable source of water, right? And, we took some coliform tests with us, and of course, those came back positive. So it's, again, not a source of water that we want people to be drinking from, and they didn't want to be drinking from. So that was kind of the impetus for this project. Hopefully I can start sharing my, go back to, let's stop sharing here. And then I'll present in Teams again. So hopefully this loads. There we go. Just gotta go back to the start. Sorry for jumping around here, but
You're doing great.
Perfect. So, yeah, that was kind of the issue, right? So during the rainy season, abundant water for at least half of the community, but then for the other half of the community, they just had that vulnerable source. So what we wanted to do is develop a year-round source of clean, reliable water to the community in a way that, and so we knew that we'd have to pump it, and the electrical grid out there is pretty unreliable. They do have it, but it's very basic. The infrastructure hasn't been built out. So what we decided is that a solar powered pump would be the best option for drawing groundwater from a shallow well. And then from there, we would pump it up to San Francisco, which is on the hill, and then it would flow down from the reservoir back into the distribution system. So it's a pretty unique system where we're using the same distribution pipes to pump the water from the groundwater source to the reservoir. And once the reservoir is full, then we drop it back down. And we do treat the water before we pump it. So, you're not just mixing dirty water with clean water. So it's all treated before it gets pumped up to the reservoir. I can move here. So this was kind of the timeline of the project. So back in 2019, we flew down there. I was not involved at that point. I was actually still in Peace Corps. So I was in country, but far from here. And so we went and inspected that existing infrastructure that they had, saw kind of some of the lapses, the gaps in the community on the north side, and then started our assessment evaluation. So there were a couple of different designs, and eventually we landed on this solar-powered pump. And then in 2020 is when we were supposed to have our first implementation trip, but of course COVID broke out, so that prevented us from traveling. So we were able to do some remote implementation with some contractors and people from Chuchurras as well. So that was that started the well siting, the construction of the well, and the well house, which these people are standing upon right now. And so in the second implementation trip, that was in 2023. That was when we installed the solar panels on top of the roof, built out the distribution system, installed some communal taps, and then put in the first set of reservoir tanks. And then in 2024 is when I traveled, and that was the third trip. So just some pictures from that initial assessment trip. So you can see that in the left picture here, that was their existing reservoir. Again, not very, it was pretty antiquated, pretty old. It wasn't very high. And if you obviously work with drinking water or work with any form of water, you know that you need elevation to, develop that pressure to get water into the distribution system. So, being that you're kind of in, a low-lying basin, you don't have a lot of hills to work with. So the community did as best as they could on that south side, but it's just really not that. There's really just not so much topographic variation there. So part of that, our trip was to find something higher. What is a place that we could put 10,000 to 40,000 liters of water, and deliver that throughout the community. So we met with the community. We had a big communal meeting in which both residents from both communities came and kind of voiced their concerns and their needs. And then we came back to the United States. We did a lot of the engineering analysis from the data that we gathered from the initial assessment trip. And then we're like, okay, great, we're ready to travel. And then COVID broke out. So during COVID, I think this was actually taken in 2021. So I think most of these people had vaccines by this point. So I noticed they're not wearing, doing a lot of social distancing, but I think by this point, that had made it down to Peru. So being that, we didn't have a lot of, the fancy, augers and drills that we have, kind of mechanical or motorized. A lot of this was hand dug, so hand augering some of these soils to understand what was below the surface level. We came back with some analysis. This is actually just from the surface here. As you get closer to the water source, it becomes a lot more clayey and compacted and moist. And so after that initial hand auger was done, they cited a location in Ben-Hamin, which is our lead contractor. He's from the community. He's also just a full-time carpenter that splits time between Lima and Chuchurras. He came back to the community to help implement this project. And so they were able to build what is essentially a hand dug well, which is a misnomer because they used an excavator to drill this well. It's not very deep. I would say it's probably 10 to 15 feet to the groundwater or to the water table. But from there, they were able to build the casing. And so this is kind of a very accelerated timeline or photo log. So they grouted it, built the casing around it, and then elevated above the floodplain, or the what we thought would be like the 100-year flood. So this is actually just half of the height of the finished. You can see maybe on the right-hand side of the screen there. It protrudes about 6 to 7 feet above the finished surface elevation. And so yeah, they were able to I don't know how they got the water out, because we hadn't installed the pump by this point. Maybe it was just kind of an artesian thing. But yeah, that was a really big moment for that community, and able to find groundwater that was cleaner and more protected than some of the surface water sources that they had. And so they were all able to do that on their own. We didn't have boots on the ground at all at this point. By the first time that we made it to community was in 2023. Once we had that well built. So another thing that's kind of missing from these pictures is that Ben-Hamin actually built the well house around this well. And so from that, once we had kind of that water source secured, we started building out all of the distribution system, and the community showed up in force. We had probably 50 to 100 volunteers helping us. They did not dig all these trenches by hand. There was definitely an excavator there, but a lot of it was, putting the tubes together, making sure that it had a nice, a fine layer of base underneath of it so that it was protected, and then backfilling it back in. So again, we did a lot of that with an excavator, but a lot of the manual work was just placing and securing that pipe. So you can see a little bit more of the well house here. That's where the well is inside of that. So we installed some valve boxes to just be able to control the flow to and from the source, just from the source. And then that occurred while we were in country. This is a picture of that finished well. And this is when we were installing that pump. This is Paige, one of our volunteers, installing a Grundfos SL 900, I think it's called. I think I'm mixing my Hawk chemicals or my Hawk instruments and my Grundfos instruments, but that is one of their pretty awesome products from Grundfos, which is a solar pump. And that is what delivers the community their water. And so we installed that in the well. And then this is a much better picture of that finished well building, or the pump house, I should say. So once we got kind of the roof in place, we secured these solar panels, which obviously power the pump. And I wish I had an actual flow rate for you. I could make one up off the top of my head, but I'm not going to do that. So this was another amazing kind of feat for that community. It was to build something of a state-of-the-art facility for that region to get water from a groundwater source, because we take kind of wells for granted here in Minnesota because we have so much of it. The groundwater is so abundant, but there in Peru, a lot of communities rely only on surface water. So having something that can draw filtered water out of the ground is a huge step. So we're really hoping that this kind of serves as a format for communities. I'm glad that you don't take wells for granted, Michael. I know we're getting up on time here, but so in October 24, after we built out the first part of the distribution system, we wanted to expand that as well as update a lot of those reservoirs so we had installed 4 tanks, but we wanted to quadruple that size, and then install the chlorination system, automate that pump, as well as install some communal taps. As you can see here, this was actually just a picture. This is what happens when this is from the celebration at the end. Chris brought some manufactured snow from Minnesota. So that was kind of our token. And all the kids, of course, just pounced on it like vultures. This is how we got to site. It took us about 7 hours to drive 770 miles, which included a couple of river crossings on these kind of ad hoc flotillas. So this was like 2 river boats slapped together to get your car across. So that was a very unique experience. We ran into some road construction, saw some cool birds. So yeah, this was the project here. So this is the community again. So the stars you'll see here on the Santa Rosa side, that is where the well is. That's where the pump house that we just saw is. And then you follow the blue line, and that gets you across the river, all the way up the hill to San Francisco, where the other star is, and that is kind of where the reservoir is. So that's the high points between both of these communities. So between the stars and the blue line, that was the implementation 2 trip, and then all the red lines are the distribution system that we built out during the 2024 trip. So in implementation 23. So that is what the distribution system looks like. The whole water system looks like at pretty much up until this moment. We are going to expand it as well as include more communal taps. So originally when we arrived, I wish I had a better picture, but we had one of these tanks. So we had a capacity of basically one of these tanks, but they were all smaller, 2,500 liter tanks. And we basically relocated those and installed these larger tanks. So they all have 10,000 liter capacity, and there's 4 of them. So that's 40,000 liters for that community. And then again, that's at the high point of the community. That's actually much larger than their daily needs, but we're anticipating growth in this community. So we'll have room for them to grow in that community. Again, we built out the distribution system. So we were doing a lot of the trainings on how to properly install PVC pipe using glue and primer and so on and so forth, holding it for the correct duration, securing it, putting a proper bed underneath of it. This was lower in the screen here. This is kind of the work we did to put some of that sub base below it. And a lot of it was just schlepping the dirt from one pile to another and making sure that we had proper alignment, proper depth there. And so not all of it got installed. I would say we're about at 80%. We still have a couple of places in the community to reach. And then here were some of the taps that we installed. So once the distribution system more or less came to a location, so we're not delivering water to people directly in their house. What we're doing is that we'll have communal taps. So we deliver like to a tap stand around a cluster of houses. And so we just didn't have the budget or quantity of water to get water to people in their house. So our compromise is going to be, getting places to where water is needed by the most amount of people. And so that's where we have communal taps there. We also have taps and dedicated reservoirs at like the health post here in the middle picture. And this is just kind of the first tap that we installed back in the 2023 trip on the left picture here. So we installed the pumps, and so ideally they're going to work automatically. However, we're still troubleshooting on how to get that automation. So at the moment they work manually. Ricardo has to go to the pump house every day and flip that on to send water from the well to the reservoir. So we're hoping to get about 75 pounds per square foot. Again, I wish I had a flow rate for you, but that is kind of how we're working there. We do have a chlorination system that we elevated up on the wall here. It works a lot like a pool chlorinator, in which you manually feed like chlorine discs into, and as the water passes through those discs, it chlorinates it and gives a residual into the distribution system. So again, that'll be securing that chlorine and making sure that they have a proper supply chain is what we want. And then, yeah, that was kind of the extent of what we were able to install. So we upgraded the tanks, we expanded the distribution system, we installed a treatment system, and then kind of, unfortunately, we didn't make a ton of progress with the pumps and controls. We were able to like get a better electrical connection there, but again, we still have to kind of troubleshoot and do some automation. And then, yeah, this was, so actually on the left here, this is the very first day when we arrived in community. So that's what the reservoir tanks that they had. So those are much smaller than the larger ones we were standing behind. So this, all in all these blue tanks were like 10,000 liters. So we basically quadrupled that capacity. And then, yeah, they had a huge soccer tournament there while we were working. So that was kind of an interesting traffic jam. We had a big community celebration. We got invited out into the community to kind of, I don't know, just explore, how they lived in their everyday lives. So yeah, here's the much larger tanks, and everyone, basically all of the travel members are from Minnesota, with the exception of Brian. He's from Iowa, but they all work within our chapter. And then these are the community partners, kind of the leaders here. So we have Juan, who works with the NGO. We have Jessica, who at least was at that point was essentially the mayor of that community. She has now been, since she stepped down from that role. So there's another mayor, and then there's Ricardo, who is the town's operator and Haas president. He's kind of that water committee president. And then there's Sarai, who lives in Lima, but she helps the group with translation and kind of community connections. And so, yeah, this is basically all that we have left to do. I won't read through all of these, but as you can see, we'll be traveling in 2026 to finish out some of these punch list items. We have a few more tap stands to install. We obviously want to automate that pump, as well as get chlorination up and running. We will be doing some operation and maintenance training. So that's kind of my role, is working one-on-one with these operators and just making sure that, if something goes wrong, what do we do? What are some of these most common maintenance items? How do we properly install chlorine? How do we, what happens if the pump goes from automatic to manual? How do we do a proper cleaning of these humongous reservoir tanks? How do we, detach them from the system, turn them on their side, scrub them out from the inside? And then, doing some more like the book work. How do we establish a water collection fee so that we have kind of this rainy day fund for like, oh no, a tube breaks or one of our reservoir fails. Like what do we do? And then how do we replace it? Who do we contact within our community? So that's kind of some of that longer term sustainability capacity building that we'll focus on in this next trip. And I would show you, I just have a mountain of photos from like the 10 days we were there. This was kind of, again, that's that community celebration. They really rolled out the red carpet for us at the end. And we all, had they cooked for themselves as well as us. But yeah, it was awesome. I could speak for another hour on this. I want to give some time for questions. So thank you. And yeah, I will. Actually, I don't know if I'll stop presenting, but that's the last slide. So maybe I'll just keep it up for questions.
Thanks, Brian. That was really,
Thank you.
really an interesting talk. Thanks for giving it. If people have questions, throw them in the chat and let's throw some questions at Brian. I have one to get us going anyway. Brian, did you mention what the population of Chuchurras was? Because I didn't catch it.
Roughly 500, and
Okay.
it's tough to because a lot of communities in like especially in Peru, but developing region contexts, it's you kind of almost have like two homes, right? You have the place where you grew up, but you have the place where you work, and you might still have property back in the place where you grew up, which is technically your home. So that Chuchurras is definitely emblematic of that, where like a lot of people work outside of the community. They work in the district capital, or they work in Pucallpa or somewhere else, but they still come back to the community. So we kind of have to like almost oversize it, because at any given point, like if people come back for Christmas, or like their kind of like town anniversary, like that population can balloon from 500 to 1,000 very easily.
So Jesse asks, can you talk about the balance of system sophistication versus ongoing maintenance and supply
Ooh.
chain issues? I think you got it right with communal pumps. House to house infrastructure would really complicate things.
Right. And that's kind of, yeah, it was like, how can we deliver a good system without making it impossible to, and to be honest, like there's a lot of systems, like when I was in Peace Corps, we all had house connections, so that exists. But one thing that especially when you're in a place that has a resource that didn't have like access to a resource that now has it, what I found in Peace Corps is that like when you don't have like metered connections, people will be like, oh, well, now I have water that I can use to not only drink, but give to my animals. I can use it to water my plants. I can use it to wash my car and do all these other things. And I can just leave the tap open, right? So having a communal tap helps like kind of stem some of these, like, I wouldn't say abuses, but like uses of drinking water that aren't for drinking or aren't for like, necessary household needs. Kind of some of those basic human needs. So I think that was kind of the reason for going to communal taps, just to be able to be like, okay, we have this resource, let's try to protect it and maximize it for the community. Not to say that, and again, it just also was cost prohibitive to get it to every single house that was there. And then balancing that sophistication with like, so like having an automated pump is kind of a level of sophistication that we'll have to kind of work through. But we are writing a manual, like step-by-step manuals. We do have people who know how to use that system within the community. And then using gravity flow. So I guess that's the only electrical component within the system. And then if you get up on top of the hill, it's just gravity flow again. So it is, yeah, it is like a nice system, but it does kind of have some inherent complexity to it.
John asks, are the locals equipped to sample water on an ongoing basis? That was one of the questions
Ooh.
I had too.
Yeah, great question. So that is something that I've kind of been pushing for. At the moment, they do not, because we're not even chlorinating. So in the sense, it's pretty easy to like measure chlorine residual just with like DPD tablets and colorimeters. Those are really basic tools. But if we're talking about doing things like bacteria tests or testing for metals or testing for all sorts of other things that we, in the state of Minnesota, we test for over 100 contaminants, right? But if we're only just measuring like bacteria, we're missing a large part of the picture. However, that's in Minnesota when we have, the state-of-the-art public health lab, excuse me, in places like, in the Amazon of Peru, you don't have massive labs to test all these things. So doing a bacterial test, like that would be a leap forward. But as good as we can do right now has been some of these like color strip tests. And I know a lot of you may be groaning because it's not an adequate test. But what we can do is try to get like the public health lab, or sorry, the local clinics to come out and take a bacterial sample. And I've contacted them. I've tried to because there are labs that they can send it to in like the district capitals or in Lima, but getting that resource has proven very difficult because they just don't have, they're just not allocated those resources to get a bacterial test or get like a metals test or something of some sort, because they're very expensive and testing for that may not even exist in Peru.
Aida wonders, are the tanks in the ground or on top of the ground? How do you clean the inside?
Great question. So no, they do sit on a concrete pad. You can kind of see that in this photo here. So we have a little hut, and then there are 10,000 liters tanks that sit on top of a concrete pad. And then basically, I don't know if you can really see it super well in these photos, but you can uncouple these tanks from the pipes that are standing up to them. You would obviously have to drain them first, and then it takes a couple of people to kind of, I would say a couple of people at least, to shift them out of that pavilion and then tilt it on its side. And then there's a maintenance port on top of these tanks that they can, which is an enclosed space. And I have reiterated many times that they should do this in teams and not do it as a person. So yeah, it's not a perfect system, but the maintenance is possible. And then
she also wondered, how do you raise funds for these projects and for the engineers to travel?
Yeah, so great question. So for, there's a whole range of it. So some really well-funded Engineers Without Borders programs, they cover all of the expenses, including travel. That's not the case for us. So like we are responsible, the travelers are responsible themselves for like getting the ticket to and from Peru, but all the in-country expenses are covered by EWB. So I basically just paid for the plane ticket, and then anything like any like souvenirs or fun things outside of that I covered. But then the fundraising aspect is, yes. So a lot of it is through donations. So we have like corporate partners through a lot of the engineering firms in the cities donate to us. It's a lot of hustling. It's a lot of, I shouldn't say hustling, that's a bad word. It is, but you are trying to fundraise within the community and try to find people who, like, there are private donations, there are corporate donations, there are pots of money and grants, I think, that we're eligible for. So it is a real patchwork of money that we end up, like pots of money that we try to accrue for these projects. And I'm not doing a great job articulating exactly where that comes from, but there is like local fundraising. There are like larger pots of money that come from, like I say, corporations and things like that. But it is a nonprofit, so anything that we spend has to be kind of meticulously followed and tracked, and we've been able to fund the entire project. This project costs about $122,000 in total. Much of that coming from equipment rental for digging those trenches and excavating the well. But yeah, that's where a lot of it comes from, and contractor work as well. So.
Well, we are at 10 o'clock. And I don't see any other questions in the chat. So if nobody has anything else real quick, I'm going to thank Brian for all of us, on behalf of all of us, for a really interesting talk. Really interesting to see the kind of work that you're doing down there, and what effective work. It's really, really interesting to see. Thanks for being with us this morning to talk about it.
Absolutely. Yeah. Thank you for having me. Appreciate it.
Thanks, everybody.
Thank you.
Have a good day.
Bye-bye.
Thanks, Brian.
Yeah. Take care now.
Yeah.
Yep.
Thanks.